So the first thing I would like you to do is write the equation for this piecewise function that we have on here. So pause it right now, write the equation. Cool. Hopefully you just did that. So you should be like, okay, well, f of x, and we know it's a piecewise function. First, I'm going to start with the equation of that right there. So I'm going to say, okay, I know it's a line, it's linear. I need a y-intercept, but I'm looking here, I see a pretty clear slope, right? So if I'm going right here, that's where my next y-intercept is going to be. So it's going to be at 2. So y equals something plus 2. And I know we have a 1 and a 1. I know my slope is positive, so we have 1 over 1x plus 2. Okay? So I got that part of it. Let me make sure this is good. And so now what I'm thinking about is, where is this thing good? What's my x restriction? So it goes from negative infinity, right? And it's always going to be greater than. Now it can't be equal to negative infinity. And it goes all the way to, and it is equal to negative 1. So there's my restriction right there, you know. So x goes from negative infinity to negative 1. Okay? All right, so my next one is going to say, what's it going to say? Give me a second here. And actually, we don't even need to put that there. Okay, so the next piece I'm going to look at is this. I'm seeing this red line is a constant. So I know that there's going to be there's just going to be y equals something or x equals something. In this case, I believe it's going to be y equals 1. Because no matter where I go on this line, y is always at the level of 1. X could be 1, y is 1. X is 2, y is 1. X is 3, y is 1. X is 0, y is 1. Okay? So that's going to be where y equals 1. And that is good from where x can be from negative 1. It can be equal to negative 1 and equal to positive 1. Okay? And then my last one, ooh, this one is tricky. I didn't actually notice this right here. Let me see what they did. Yeah, that's what I thought. Okay. This last one, notice this is not really a straight line. This is a curve. This is a piece of a parabola. Okay, so hopefully you notice that, like how this is really clearly straight right here, and this one has this curve to it. I didn't even notice that to begin with. Bows. Let's see. So I'm going to say that this is probably some piece of a parabola. It probably goes something like this. So I'm going to know that it's y equals, I'm going to say it's y equals x squared. Now, problem with this is I need to actually test it. So I see a couple points that I can test. This looks like a nice pretty point, and I know this is a nice pretty point. So let me see. I see when x is 1, y should equal 1. So let's see if that works. When y is 1, x is 1. 1 equals 1 squared. Okay, so that's good. But I also need to check out when x is 2, y should equal 4. So 4, 2, boom, boom, boom. So this is actually just a simple y equals x squared. And again, we're not going to give you anything crazy on here, okay? So this is y equals x squared. So I'm going to say y equals x squared. And then I'm going to say this is good when x goes from 1 to infinity. Right? So I just wrote the, what is this? The piecewise function for this one from the graph. All right. Next up, I'm going to tell you that f of x equals, and you should write this down, negative 4x squared, wrong, minus 6x plus 7, g of x equals 8x squared plus 9x minus 12, w of x equals 3x squared minus 10, and k of x equals x plus 4. I want you to go ahead and find me w of x times g of x right now. Cool. You just did that one. Hopefully it was pretty easy. You said, okay, well, here's g of x. I need 3, 8x squared, 9x minus 12. Here's w of x. I need 2, 3x squared minus 10, 24x to the 4th, 27x cubed, negative 36x squared, negative 80x squared, negative 90x, and positive 120. Okay? I do that and I put this all together. 24, 8 times 3 is 24. 24x, wrong. 24x to the 4th, that one is used. Plus 27x to the 3rd. See, 2 sets of x squared, negative 36 and negative 80 is negative 1, what is that, 106? 80 and 3 is 111, 116. Negative 116, x squared minus 90x plus 120. Okay? There's my final answer. Hopefully you got the same thing. Next one I would like you to do is w of k of x. Now notice, go ahead and do that. Hopefully you did it and you recognize that this is a composition. This is where you're taking k and putting it in to w. Okay, so I'm going to start off with w actually. So w of x is 3x, oops, excuse me. W of x is 3, and in place of x, I'm going to put a blank, 3x squared minus 10. And I'm going to put the k inside of that. That's going to say x plus 4. And now I need to go ahead and simplify right here. So x plus 4 squared is x4, x4, x squared, 4x, 4x, 16. So that is x squared plus 8x plus 16 times 3 minus 10, which is 3x squared plus 24x plus, I have no idea what 16 times 3 is, 48 plus 48. I'm going to erase some stuff just to make my life a little easier. All right, and I probably forgot something. Oh yeah, minus 10. You guys forget to do this part often. I see that happen all the time. So my final would be 3x squared plus 24x plus 38. 48 minus 10. Okay? All right. Next one that I would like you to do. Last one of this type. So we did a multiplying. We did a composition. I'd like you to do f minus g of x. Cool. As soon as I get subtractions, I like to write them out. So I say f of x is negative 4x squared minus 6x plus 7 take f minus g. 8x squared plus 9x minus 12. And remember, we want to actually distribute this -1 so it actually becomes a positive, and then everything else switches. The sign, negative, positive. And now I can just set this up. Don't like me so much right there, huh? Now I can just set this up. What do we have? We have squareds, we have x's, and we have regular numbers. And I can always now just add -4x squared minus 6x plus 7. -8x squared minus 9x plus 12. And again, the whole point of this is so that I can just add here. -12x squared minus 15x plus 19. There is my final answer. All right. Second part, done. Compositions, we did piecewises. Finally, let me go ahead and erase this stuff right here. Finally, last thing we're going to do is a little bit with inverses. So, find the inverse of, let's go with this one, y equals 7 to the 2x minus 9 plus 10. And the second one, actually, you do the first one right now. Cool, hopefully you just did it and you said, okay, I'm going to start with x. I'm going to multiply it by 2. I'm going to subtract 9. I'm going to take 7 to that power. And I'm going to add 10. Okay? And now I'm going to go ahead and do my inverse. I'm going to take x and I'm going to subtract 10. Now, I'm going to take this whole thing. And the opposite of 7 to that power is going to be the log base 7. So I'm going to take this to the log base 7. So it's going to be log 7x minus 10. You could write it like that if you want. Now I'm going to do plus 9. So it's going to be log 7x minus 10 plus 9. And finally, and I'm going to have to write mine. Ooh, look at this magical stuff I can do. I'm going to take this and slide it over. Boss! I am going to finally, I did minus 9. I'm going to divide by 2. So I'm going to take this whole thing. Log base 7 x minus 10 plus 9. I'm going to take that whole thing and divide it by 2. So if this was, and I guess I probably should have written this like so. This is f of x. You might want to change yours. The inverse is log 7x minus 10 plus 9 all divided by